Hello everyone. In previous video we have understood nucleophilic substitution reactions of haloalkane in which X was substituted by stronger nucleophile. For substitution reaction we were using some reagents. Out of those reagents, these are the four reagents: KCN, AgCN, KNO2, AgNO2. Why we are discussing these reagents in this video, let's try to understand. When Rx reacts with KNO2, we know in potassium nitrite, nitrite part is a nucleophile. So it is going to substitute Rx, which is weaker nucleophile as compared to nitrite. Bonding with R will be done through oxygen site, like this. Alkyl nitrite will generate. And X will come with K, so Kx will be the side product. If same Rx, I am going to react with silver nitrite. Now bonding will be through nitrogen. And nitroalkane will generate. Side product AgX. First we will understand KNO2, AgNO2, and then same topic is there with KCN and AgCN. Nucleophile is same, nitrite, nitrite. Then why we are getting different substituted products? Here alkyl nitrite and here nitroalkane. Please check the difference between them. In alkyl nitrite with R, who is making bond? Oxygen. And in nitroalkanes, who is making bond with R? N. Let's find out the reason. If I talk about KNO2, number one, it's a ionic compound. And AgNO2 is a covalent compound. Now KNO2 is an ionic compound, so when it break, we know ionic compound break in two parts, cations and anions. It is breaking like this. Nitrite part. Now suppose in this condition it is going to react with X. Now X is negative, R is positive due to electronegativity difference. So we know K positive is going to attack on X. Bond will break. R will release out with a vacant orbital. Now this vacant orbital wants electron. Who can provide electron? Electrophile. Nucleophile. Now in this nucleophile we have three atoms. This oxygen carrying 3 lone pair, this nitrogen carrying 1 lone pair, this oxygen carrying 2 lone pairs. Now which atom is in best state to provide it electron? This one. Because right now it is carrying 3 lone pairs, which is making this oxygen unstable. So this oxygen is ready to donate electron to R very easily. So the bond formation will be through oxygen side. And alkyl nitrite will generate here. Whereas in this reagent, silver nitrite, it is a covalent compound. So it will not break like KNO2. When Rx reacts with AgNO2, so it is carrying a negative charge, it is carrying a positive charge. Now this positive charge will attract lone pair of electron. This R wants electron. Who can provide electron? Three atoms are in position. Oxygen with 2 lone pairs, nitrogen with 1 lone pair, and this oxygen with 2 lone pairs. Now in this condition, which atom is in best for donation of electron? That is nitrogen. Reason: oxygen electronegativity is more than nitrogen. Their electronegativities are 3.5, 3.5, and nitrogen electronegativity is 3. That's why nitrogen can donate lone pair easily as compared to oxygen. So, nitrogen will start donating lone pairs to R, bond will break. This X negative will be stabilized by silver because silver is less electronegative than oxygen. So when bond between silver and oxygen break, both electrons will go toward oxygen. R will make bond with nitrogen. Now because nitrogen is using its lone pair, so dative bond will generate. It is already bonded with this oxygen, and this oxygen will get electron from silver, so it will become negative oxygen. And silver will release out as a Ag positive, which will react with X negative, so AgX will generate out. Now here bonding is through nitrogen, and the compound formed will be known as nitroalkane. So this is the reason. KNO2 is an ionic compound. Oxygen is in best position to donate electron to R because oxygen is carrying a negative charge, unstable it is. Whereas AgNO2 is a covalent compound. All atoms are in neutral condition. In this condition, only nitrogen is ready to donate electron to R because nitrogen electronegativity is less. That's why bonding will happen through nitrogen side, and compound generated will be nitroalkane. Same reason is there with KCN and AgCN. KCN is ionic compound. It will break in two parts, K positive, Cn negative, where AgCN is covalent compound. Now check. Rx reacts with cyanide. So obviously this is common to all, that Rx bond will break and X will get electron, due to which X will become negative and K is positive. So X and K will combine, and what they will create? Kx. And R will release out from here with a vacant orbital. Now it requires electron. Nucleophile can provide electron. Here we have nucleophile. But in this nucleophile, two atoms are there which can donate electron, nitrogen and carbon. Which atom is in best condition to provide electron to it? Carbon. It is carrying a negative charge, unstable it is. That's why it is ready to donate electron to R. And second reason is bond generated will be between carbon and carbon. Carbon-carbon bond is strong as compared to nitrogen-carbon bond. That's why two reasons are making attack of carbon on R, and RCN will generate alkyl cyanide. Bonding will be through carbon side. Whereas in this case, if we react it with Rx, X is negative, R is positive. R positive wants electron, nucleophile can provide electron. This reagent we have. Now which atom is in best condition to provide electron? Nitrogen. Nitrogen is carrying a lone pair. Carbon don't have any lone pair. Secondly, nitrogen electronegativity is more than carbon. So most of the electrons are toward nitrogen, due to which nitrogen have a partial negative charge. The negative particle can easily attack on positive particle. That's why in this case bond generated through will be nitrogen. Between R and X, bond will break. R is getting electron from nitrogen. The nitrogen will make coordinate bond with N. Nitrogen will make coordinate bond with R. And between silver and carbon electronegativity is more. So bond will break like this. Electrons will go towards silver and silver will release out here as a Ag plus 1. Ag plus 1 will be satisfied by X. So side product will be AgX. And 3 bonds will remain as it is, and this carbon, because it is carrying a extra electron of silver, will get a negative charge. And nitrogen, because it is making a coordinate bond, a fourth bond, so it will carry a plus 1 charge. Now what is this compound? This is alkyl isocyanate. So these are very, very important questions. Like when Rx react with KCN, haloalkane react with KCN, the compound formed is alkyl cyanide. And when same haloalkane reacts with silver cyanide, the compound formed will be alkyl isocyanide. Our Rx reacts with KNO2, giving us alkyl nitrite, whereas Rx reacts with silver nitrite, giving us nitroalkanes. Why? These are very, very important questions in nucleophilic substitution reactions of haloalkane. So here we have reasons. That's it. This is the end of the topic. Thank you very much.